Okay. Now I just suddenly realized we may have a problem. How can I make somebody the presenter? We were having trouble earlier with, how do I make somebody the presenter? Okay,
Don, at
well,
the
let me
bottom of our screens, at the bottom of each of our screens, if we move our mouse, we see a display at the bottom that says share screen. We can elect to share our screen.
well, that will work. So I'm going to stop
Well, we can try
sharing.
it.
Okay. Well, let me ask a question. Is there anybody who's, for our show and tell, I know I've got one student was already interested, and I have a feeling I know what he's going to show, but Carlos, are you on the line?
Yes, I am. Can you hear me okay?
I sure can. Do you want to be my first volunteer for the night and show? I have a feeling you're going to show. What was it? It's that program. It's
Come on, you can do it. Come on.
it gives it the letter A.
Microsoft Azure.
Azure. Thank you. Thank you. I couldn't remember Azure. I think Azure means blue in another language, but I
It
don't know.
does, yes.
But I don't know why. Well, who knows? Okay. Do you want to be my first person for the night?
Sure. Can everybody see my screen?
I definitely can. Now, guys, today this is called Show and Tell, and it's open for everybody, even the 411 students. You get 10 minutes to impress us, and you don't want to go into the weeds. You want to give a quick overview with just enough that people are like, I think I can figure this out. I see the value. If you crawl into the weeds and everybody's eyes glaze over, they're not going to watch this or they're not going to do this. The thing is, if somebody uses your idea, even if it's a 411 student, if a 411 student says this is how you do something, and a 498 student says, I tried Bob's idea from 411, I will give Fred from 498, I'll give you bonus points for trying something new, and Bob from 411, I'll give you bonus points because you exposed everyone to a new idea. But you have to make sure that when you write your paper up, you put a big red box around it and say, I got this idea from this person. So I'm not a mind reader. So you got to help me out, people. So keep it simple. I'm going to stop you at 10 minutes, and it's not fun when I have to stop people. So anyways, does anybody have any questions or comments? Because make sure, oh, and also, Carlos, what's your team? Because your whole team gets some of the bonus points too.
We're the Pump It Up team, the
Well,
Well
I know.
team.
What team number is that? Would you happen to know?
Susan's on the line. I think we're 2.
Yeah, I think you are
Yes,
too.
we are. We're 2.
Okay.
Yes.
Okay. So anyway, Carlos, you go get them. Okay.
Okay. So I decided to try something new. So throughout this whole program, we've done R, we've done Python, we've done this antiquated language called SAS. Just kidding, Don.
Ouch.
Just joking. But I wanted to do something different because as I go out there and I start talking to companies, people are saying, what have you done with Amazon Cloud? What have you done with Microsoft Azure? So I thought, why not as part of this team competition, I try building a model in Azure, a machine learning model in Azure for our data set. And it took me about half an hour to learn Azure. And then once I learned it, I built my entire model in 15 minutes. It's not perfect, and I'll show why later on, but it saved me about 7 hours of coding. And I was pretty shocked. So let me explain the layout to this. So everybody gets a Microsoft Azure account as a Northwestern student. I have a tutorial that I put together, and I'll quickly walk through that in a few minutes that shows you how to set up your account, but also how to build this model with this data set using data hosted on Driven Data. But basically what Microsoft has done is they've made this all drag and drop. So there are ways to import data. There's machine learning widgets. There's scoring ones. It's pretty impressive. And also, one thing Microsoft was very insightful about is they said if there's something you can't do in Azure, you can do it in R. And they put in support for supporting everything you can do in RStudio. can be done, including any library you want, can be done in Azure as well. So I could always link this to R and then have R output going out. So if there's some model or some function, or if I want to use a feature of mice or want to use ggplot2 for plotting my graphics, I can do it in this and output it to the screen quite nicely. So one thing I like about this is it doesn't bog down my PC. This would probably take about 10 minutes to run on my PC. Takes about 1 or 2 minutes to run on Azure, and I have a lot of extra checkpoints in here as well. So just let me walk through this very quickly. Basically, I import my data from a website. I tell it to cache it so I don't download it each time. I convert it to a data set, and this basically tells you to store it in the Microsoft Azure database. I join 2 different data sets because my project has 2 different data sets. And whenever you see these convert to CSV, I just did these as a sanity check for myself. Every now and then I want to throw out my data to an Excel and check the progress. Cleaning the missing data. This is where I get really lazy sometimes. And basically I told Azure I had a bunch of data that was, I had a bunch of missing data, and I thought, well, what's the quickest, dirtiest way to impute it? Mice is a really nice function. It's available in R. It's probably available in SAS for imputing missing data. It only works well for small data sets. Susan Poole on our team did it by hand in R using mice, and she used decision trees too, or a random forest, and she actually showed that the random forest was actually more accurate. So it's not the most accurate thing, but a lot of times it's good enough. And Azure gives you a whole bunch of other methods to impute missing data, and then you can also do it in R or do things by hand. You have to normalize the data. I split my data here. We all love splitting our data. So this did it really quickly. And then I picked which type of model I wanted to use here. I just dragged it over, and I wanted to use a multi-class decision forest because I'm predicting 3 things. Then over here, you can score your model. It can, let's see if I still have my results cached here. I can even ask it, how did my model do? It can give you your confusion matrix, show you how you're doing. Depending on the model, and this is something interesting, it will pick the best method for evaluating your model, be it a ROC curve, a confusion matrix, or other things. So you have to be careful which model you pick. At the end, I convert my data to CSV. And let me show you guys my tutorial really quickly. I know we're pressed for time, but I'm going to post this online today. And it's just a quick tutorial that talks about how to register for it, how the dashboard works, how to build the first model. And for the first model, I cheated. Anybody who wants to go through our tutorial, guess what? You're going to be doing our capstone project. So you get to repeat it, but once you do it, there's no reason you couldn't build your own model with your own data or load up your own data and do it just as quickly. So I make it really simple. I say go to the Driven Data site, grab the links for the data, keep them somewhere, and then once you're ready to begin, I just talk about you want to look for the input section, drag import data there. It can even handle zip data files too. Sometimes we get big zip data files, and it's easier just to upload the zip data file to Azure or point it to one. It can handle all that and decompress it. The other nice thing about it is I tried it with some time series financial data, and I told it not to cache the data. So every time I ran Azure, it would re-download the data and refresh it. So you have to consider about if your data is kind of stagnant or stale and doesn't change often, you're better off just telling it to cache the data. So every time you run your model, it doesn't have to go through it. But this is the true dummies guide on how to configure this. There's not a single step that I don't miss in terms of breaking this down for you guys. And over here, you can see how you have see, I'll make this a little bit bigger for you guys. How you can see we have the two different data sets that are coming in. One thing that's important is you see these little green arrows. Every now and then you want to run the data set. And it's basically what we're doing in a lot of our other languages. You run it as you go along to check your progress and make sure you don't get errors. So if you get an error, you get a little check mark there, an exclamation point or something else where that green check is. I talk about how to join the data. See, I got a little error here because I hadn't run it yet. You have to configure the join properties. And what's important about this is when you're joining data sets, you're not picking every column. You're picking the couple columns that make up the join in each table. And then you have to pick your join type. So I just told it to do an inner join. Also told it not to keep the right column, the key columns, because I would end up with duplicate columns then. So basically, I try and make it as simple as possible for everybody. Talk about how to configure the property steps. I skip the EDA steps because I don't want to give everything away. But sometimes for your first model, I just go out there and build something quick to see how well I can do and how successful I can be without going crazy doing a lot of EDA. And Azure kind of spoils you. In terms of the clean missing data widget, I talk about dragging over the clean data. You can do all sorts of transformations in there, mathematical ones, ones on individual columns and everything else. So there really aren't many limits. And I talk about configuring the properties. Now, something with mice is you can configure how many iterations to go through and what you want to do with the missing data. And over here is always keep reminding people to retest. And I'm going to post this PowerPoint for everybody. I talk about how to eyeball the data, and this is something I learned in Don's class. Sometimes I'd have problems with my code or other things, and I just dump my data or look at it or explore it every now and then. In Azure, you can just, if you're lazy like I am, you can convert it to a CSV and look at it in Excel. There are other ways just to look at smaller subsets of the data, but, to each his own. One thing that's really important with machine learning models is you need to normalize the data. And I just remind people about that step in here. And also splitting the data set. Remember, we have training, you got to split your data sets to train your model and test it. So I go through those steps, explain some of the nuances here, explain one of the things with Azure, and I found it a little overwhelming, is there's so many different machine learning models to choose from. And those of you in the SAS class, there are a bunch of regression models in there too. So it's not all machine learning. There's plenty of regression models you can choose from. Sometimes a regression model works better than a machine learning model. So you can't say one method is better than the other. It just depends on the business problem you're trying to solve. But again, this makes it kind of easy that you can throw something together and see what happens. In this one, I chose a 2-class boosted decision tree. You can see that there. And then over here, I go through scoring my model as the next step, evaluating the model, remind you to run everything. And I'm calling this the faux Mona Lisa for a reason. This looks like a great rock score. It's absolutely wrong. And when I first made this mistake, I thought, you know what? Let me keep this in the tutorial because this looks so good and I was so excited. And then I realized I only saw 2 dimensions to my data because I chose the wrong model, machine learning model. And Azure picks the best evaluation criteria. So I should have had, so here it is. I used the wrong machine learning model. I chose a 2-class decision tree, which is good for binary answers. Yes, no, it's broken, not broken, functional, not functional. I needed three outcomes for my prediction. So I tried a multi-class decision forest instead. Just took me about 10 seconds, 20 seconds to replace it. And over here, you can see it's looking better. You see my, you can see my uh, some of my results there, my confusion matrix results. You see functional, non-functional, needing repair, or I think it's functional needs repair. So unfortunately, it cut some of it off, but I actually pulled it up in Excel later, just to show you guys. And let me see if I can zoom in here a bit. Now, it won't let me zoom in, but basically, for those of you with amazing eyesight, you can see when I converted to CSV, I had some functional predictions, some non-functional predictions, and functional needs repair. So one of the things I noticed is you have to be careful with the length or the size of your what you're trying to predict or the variable you're trying to predict, because in this case, it got truncated. So I can't tell which one is functional and needs repair and which one is functional. I can tell the non-functional one. So you got to consider some of those things. And then I go into some tips and tricks, about how you can visualize the data set. So anywhere along the line where you have a square model, remember I dumped it to CSV, you don't always have to do that. You can visualize it, look at the histogram, look at the data. There are different ways to explore it. Here's the other one where I dump it to CSV for when I'm feeling truly lazy. In terms of what's missing, okay, so when you ask a neighbor, somebody for a recipe, it never tastes the same when you try and make it yourself. Some things are always left out. So, but I'm going to tell you what I left out on purpose. And this is something that Susan pointed out to me.
Carlos, this is Don. You might want to finish up though.
Yep, this is my last slide.
Okay, I'm loving it though.
My last slide. So basically on this slide, I'm just saying you just got to go back, and I selected all the data sets, and I tell you to do that in the tutorial for the first pass. You want to leave out some fields. You want to leave out the index, the predictor column. You may want to go back and add a widget for replacing the zeros and the data sets with blanks. Consider dropping columns that have too many missing values, and pick a better machine learning model. So that's it. So I'm going to post this for the class. I'm going to upload it tonight so everybody can enjoy it.
Carlos, could you also email it to me, and I'll post it to the 411 classes, and with your permission, of course.
Sure.
Can I post it going forward in all my classes?
Sure. I'm sure Hannah Stern will clean it up next semester like she always does.
Okay, so, my 411 classes too. I'd like to share this. And anybody in the 411 class who wants to go through this tutorial, you guys can earn some bingo bonus if you want to learn Microsoft Azure. You go through the tutorial and take screenshots and show me you did it. I'll give you points. And then if you use it for any of the homeworks, I'll give you points for that too. Because this is a valuable skill to learn. SAS is cool and it's very highly useful, but you're going to have to learn new tools as well.
Yeah, you're absolutely right, Don. And what happens is some companies pick standards, and they may have picked Azure as a standard, and you may have to, somebody may be in a situation where they're using Azure and R combined. So you never know what to expect when you go into a job or an assignment.
So, anyways. Thank you very much, Carlos. This was a lot of work, and I really appreciate your generosity in sharing this with the class.
Yep, and just a warning, it's about an 80% solution. Usually after I post one of these, other students add on and enrich it. So if anybody wants to enrich it, send stuff back to me and help this thing grow, that would be great.
That would be wonderful. So, Carlos, I greatly appreciate this. This was a lot of work, and this is certainly I think a lot of students and future students will find this to be useful.
Thank you.
Does anybody else care to be interested in sharing tonight?
Hi, this is Susan. I could share something.
Okay, Susan, but before I let you, I should let somebody else because your team is already racking up some points here.
Okay.
So you're on deck, but I want to at least I had one quarter where I had like an entire team went and everybody else didn't get a turn. So now I got to be careful because everyone complained. So does anybody else not on team 2 want to present? If not, Susan gets to go again. Anybody? Bueller? That's a funny reference, anyone, in case you. I must be on mute. Not a sound.
Can you hear me?
I'm laughing, but my last name's Butler, and so people have called me that all my life.
Okay. Does anybody else other than Susan want to go?
Can you hear me, Don?
I can. Who's this?
This is Jim Anderson. No, Team 1.
Team 1, Jim Anderson. Do you want to go first, and then we'll let Susan Poole go?
I will go. I will say I hate following that because mine was not nearly as put together as that.
That's not the point. The point is that you have to even if I've had people do things like one guy was showing Excel tricks and following a guy who was talking about deep learning neural networks. Guess what? Everybody was using the Excel tricks and nobody used deep learning neural networks. This is show and tell. Don't worry about following this. Although,
okay,
I'm glad I'm not you because I wouldn't want to follow that.
Well, I'll just say mine's going to be quick. I hadn't planned on doing something tonight, and then I was traveling and listening to a podcast, and something caught my ear that I thought really applied to us. So I was thinking of this more as just something I would want to discuss if I was with a bunch of people in person. So
okay.
Let's see. Begin screen sharing. I'm trying to share the screen. It wants me to add an extension.
Uh-oh.
I don't know if that. Let's see.
Don't know what that is.
Let's see if this will come up.
Something's going. Susan, don't worry. I'm not playing favorites against you, though.
All right.
I'm not worried. I'm not worried at all.
Okay. You'll get your turn tonight. When a black box can get you in trouble. Okay, Jim Anderson,
right.
You're up. And you're in Team 1, right?
All right, yeah. Mine says I'm sharing my screen, but I can't look at it and see that it's sharing. Can you?
Oh, you can share. I can see your screen.
So can you see a slideshow when a black box can get you into trouble?
Yes, I can see that.
Okay. So I was, like I said, listening to a podcast. It's NPR Tech podcast. And they did a short little thing, and it was a ProPublica examination, and it said reveals discriminatory pricing by computer algorithms. And actually, in my slideshow, when I was going to present, I had embedded an audio file about the short 3-minute podcast. But number one, you might find that boring, and number two, I'm not sure that I can share that via BlueJeans. So I'm just going to tell you real quick, what it was. It was an interview with somebody at ProPublica talking about how they had discovered when examining, they go into the fact that now all websites are so personalized that when you go onto a website, it's created just for you based on everything that they've seen about you before, all the data that they can find and all the data they have. And sometimes this can create, depending on the algorithms that are used, some unfair situations. So what they went into detail about was a Princeton Review selling testing preparation packages, and they actually priced them differently depending on who was viewing it. They got different pricing packages, and what ProPublica found when they examined it was that these pricing packages range for this particular product from $6,400 to over $8,000. I'll just show you. Let's see. Well, I was going to show you the website on there. I'll post this with the link to it. But when they examined that, they found that Asians in particular were always charged higher prices, way out of proportion than the way they were viewing it. And so when she dug into it a little deeper, they found that it may have been based on zip codes, and maybe it was possible that the Asians that they had in this examination were more likely to live in more affluent zip codes, but they also found some less affluent zip codes that still seemed to hit Asians more directly. And when they confronted Princeton Review about it, Princeton Review said that they didn't have anything in their algorithms. They were using neural networks and didn't have anything that specifically pointed to that, but that they would examine it more. And the author in the survey, or the lady in the interview, said that she didn't have any evidence that they had done this on purpose. But I hate this. The audio explains it a lot better than I am. But they did this on purpose, but it was sort of a side effect of kind of black box algorithms that we can use, and a warning sign for that. So what I wrote here was just when you can get into trouble, it depends on the application. So you may want, and when I say a black box technique, I'm assuming everybody kind of knows, but something like an artificial neural network where you can have, a massive database, put everything in there without any direction, and it will give a good output as far as, giving a good thing to go after, but not really explaining, or there's no way to explain how it came to that conclusion. And in certain situations, that can work really well. It might work really well on something like actually, it can work really well in a lot of situations, but it can get you into trouble. So something like facial recognition, handwriting recognition, that kind of stuff, it can do a really nice job. However, if you're analyzing something like banking or credit decisions, housing decisions, staffing decisions, et cetera, if you can't explain how it came up with what it came up with, you could get yourself into trouble from the standpoint of, is it profiling on something that would be either illegal, or if not illegal, at least unethical. And in those situations, you might want to opt for something instead that has explainable techniques such as regression or decision trees. So for instance, if you turn somebody down for a credit application, you want to be able to say, I turned them down based on income level, number of days past due, or whatever. You can't say, I don't know, because the algorithm told me to turn them down. And then if you did an audit afterwards, you could find out it's turning them down based on some other aspect, whether it's race, sex, religion, what have you, that shouldn't be being considered. And ways to manage the black box effect, if you are going to use that kind of network, I thought about that you could go into it two ways. You could audit the inputs, so go through the input variables, see if there's ones that you think could get you into trouble and shouldn't be something that should be applied, and just simply exclude them. Don't have them in the data set. Or you could audit the output, essentially recreate what the ProPublica person did as an outside agent, and go through what the model ended up suggesting, and seeing if you can find a pattern there. Again, that whether you can explain the model or not, you might see something in the pattern, such as in this case, Asian people were being charged at higher rates out of proportion with what they should have been, and see it, and you might realize you have a problem at that point. Along that line, I said consult a second set of eyes, which essentially is what ProPublica did without being asked to. That's what they did as an examination. I put, is it worth it? So if it's not necessarily a legal issue, and in a case like this, if it can't be proved that they were trying to target, in this way, it might be, the thing about it is with the neural network models, they might actually be the best model. Is it worth the headache of it? You might find that it's not worth the headache of the ethical implications that somebody might put on you. On the other hand, you might find that it's not going to be that big of a deal, and it really is a super model. And if you don't have legal implications, it's something that you might still want to consider. My last thing was thoughts. Like I said, I viewed this as a discussion on what other people thought about it. What it rose to me, because we were doing in my group, I'm team 1, by the way, and we were doing, some association analysis, clustering of customers, et cetera. And it just said to be, make yourself aware of, if you're not going to be able to fully explain the model, like if a neural network gives you your best output, you at least need to know and be aware that it's not being based on something that it's going to get you into legal, ethical, moral trouble. And like I said, not nearly as detailed or as applicable as what Carlos just did, but it was something that piqued my interest, and I thought other people might be interested in it.
I really like this. This is a very practical, and the interesting thing is in my new job at Sprint that we just ran into very similar, the analytics group is, we were looking at machine learning algorithms, but exactly these black boxes were giving somewhat better lift. But then when you start coming into it, you crawl into the weeds, you're like, you know what, we can't use this thing because we don't know. We're willing to take basically a slightly worse model if we can explain it, because you don't know when you're running into situations where there might be discrimination or things of that nature, because especially when you start using things like you said, zip codes and what have you, and we want to be very careful about that, because even though, especially for marketing, it's not necessarily illegal, but you don't want to accidentally sit there and, like you said, charge like the Asian people more money. There's no good's going to come of that. So,
right.
We're looking at this in a very real situation right now. At our company, we're trying to do things that's explainable just to exactly avoid this. People get really enamored with the accuracy of a model, and they don't think about these practical considerations. You don't want to discriminate for no other, even if you're not a nice person and you don't care, well, you should care, because you can get like so much bad press that it costs you a lot of money. So be careful before you use these black boxes. They're not bad. I mean, they could be wonderfully accurate, but be careful when you're using them that exactly this situation. So this is a very timely, very an excellent talk.
Great. And yeah, I thought the same thing when, we're examining our stuff within our project. I was like, it might not be worth it. And also, I should say, and actually I would recommend, it's only a 4-minute clip. I took longer to explain the interview than the interview actually took. And I'll post it with the link. It's worth listening to. But she did also, since I named Princeton Review, which she did, she made care to point out that she had no evidence that they did anything intentionally to discriminate. It just happened that their results came out discriminatory in a way that they couldn't explain. And so that's what you got to be careful of.
Can we have copies of these slides? And do you have the link to the talk?
Yeah, I'll post the slides, and I'll send you an email if you want to share with the other class. And within the slides themselves, it's actually got the embedded audio file and the link to the article. So I just didn't know if I could play the embedded audio file on Blue Jeans or not. But I'll post it to our group, and then I'll email it to you.
There might be copyright issues anyway in Northwestern.
Well, that's true. I might just take out the audio file. I'll just leave the link.
No. You could send me the link. Just don't play it on here, and then you can, let other. I don't know. I'll find out what I'm allowed to do with it. Okay.
Okay. Well, it is. I'll send the link, and it's NPR. It's a free podcast. It's not a.
Perfect.
Anything.
Well, Jim, thanks so very much.
Thank you.
So, other than Susan Poole, is anybody else? Because if not, Susan Poole gets to go next. Guess what, Susan? I think you're up.
Okay. I haven't done this before, so I'll try sharing my screen, and you guys let me know when you can see something.
Hey, Susan, what's the topic of your discussion?
Mine is completely different from what we heard from Carlos and Jim. It's going to be more technical, so total change of pace. Can you guys see my screen yet?
Not yet.
Let me try ending the show. Did you guys who use PowerPoint, did you actually?
Try sharing your screen.
Okay.
Sharing the screen works best. Your whole desktop.
Okay. So, I'm sorry. Excuse me. I jumped straight to my PowerPoint and missed the prompt.
There you go.
Cool. Thanks for your help. This is a little bit more technical, and I loved it that Carlos went through a whole project. And I'm just going to talk about a few things that we've been looking at. I'm going to share a riveting presentation about 3 easy solutions to your data prep challenges. So it's going to focus on R, but one thing that I've found is that almost anything that I'm trying to do, I can Google and find out that I can do it. So I hope that the 411 students, as you're trying to work on your project, maybe you weren't even aware that some of these options were out there for you when you're facing some different challenges. So the three things I'd like to talk about tonight are high cardinality, which I'll describe, missing data that Carlos already alluded to, and then dummy coding. And I'm just going to give you 3 quick and easy ways to deal with these situations. The first one is high cardinality. So you have this categorical variable, and maybe it has hundreds of levels. And some of our machine learning techniques or models won't accommodate that many levels in one variable. But what if that would be some way predictive? How do you go ahead and organize that for yourself? Well, there's a way you can collapse levels when you have a very small number of observations in each level. And if you're working in R, it's just this super easy little function. It's a collapse category, and I can share this PowerPoint, but it looks at your data and it says, you can describe which data field you're looking at and what percentage of the observations you'd like to set as your threshold. And I used, for the project Carlos and I are on, I said, well, 1%, let's try 1%. Of the observations need to be in a bucket to call it a bucket, and everything else has to be an other. And by doing that, we had a field that had over 2,000 levels in one categorical variable, and we're down to 11 levels. So we've got these levels that might be helpful in our predictions. The next thing, Carlos also talked about this a little bit, but missing data. So you look at your data set and you find out that you have a really interesting predictive variable, but a bunch of the data for certain observations is missing. And some of the techniques you want to use are not going to work if your data set has missing data. And our group tested 2 really slick data imputation techniques, the mice and the missing forest. And I would recommend that you try both of these to see which works best. I would actually choose these. Some people will use imputation techniques that are maybe pick the average, and I'm going to replace everybody who doesn't have a value with the average or the median or the mode. But these were both really cool techniques. I like mice. This is actually kind of doing a regression on all of the data that's really there. And it's saying, based on all of the other independent variables, we think that the value for this should be, X, Y, or Z. And this is super easy code. This is the R code again. You drop it in and you run it. Now, this took about, on a 50,000 record data set, it took about 3 hours to run this. So you go and have your cup of coffee or something while it's going. But it created a really nice result. And I know Carlos mentioned that it was a little bit not quite as strong as the one I'll tell about next, but it was really, really close. So it's just nice to consider multiple options when you're looking at this. The next one is called Miss Forest, and it's a tree-based approach. And it's known for being really good when you're looking at your non-parametric data. So we have that project that has 3 levels in the response variable and a bunch of strange categorical data in the predictor. So this was really nice for us. And the one part about this code, and I don't know if anyone else gets excited about code, but I do, this one took overnight to run for me. And that was even with specifying that my trees for this forest were running in parallel across all 4 cores of my little laptop computer. And just wanted to share this one too, in case you find your computer just chugging away and not getting anything done. Don't hesitate to look to see if you can run something in parallel. This was a really nice approach to imputing our missing data, and I think this is the one we're going to go forward with in our project based on the area under the curve for the rock plots that we created. One more potential problem you guys might see is when you look at your data you might be trying to do what Carlos was talking about and saying you sometimes have to normalize your data, and you take your categorical data and you have to dummy code it in order to use it. And in our data set in particular, we had over 20 fields with just hundreds of different levels. And I was thinking I was going to have to type that in, and I was thinking about what a mind-numbing several hours of time that would be. It was just going to be horrible. And I did the solution. I did some Googling, and there's another software package with R. And with this little tiny line of code, it generated 240 fields, dummy-coded fields from our 23 variables in just a few seconds. And I've got the link there in case you're interested in that package too. But I love finding out how to do things the coolest way in R. I think you can also go out there and Google for SAS and see if you're looking for something really interesting to do in SAS. But I didn't even know what all was possible. I thought I'd always have to do things the hard way. And I just thought it was pretty fun to share how you might do things the easy way. So I'm happy to share this. If anyone has questions or wants to know anything more about this particular set of solutions, feel free to contact me. I put my email out there too. And again, this is Team 2 in our project. We've all been working together on this. So I certainly want to give all sorts of credit to my amazing Capstone team. Love working with the people I'm working with this quarter. So thank you.
And you know what, Susan? A lot of this can come in handy for the 411 students because a lot of them are they get bonus points for redoing stuff in R. So you know what? The insurance data set and the home equity line of credit data set both have categorical variables. And you know what? Maybe converting those things into dummy variables or something like that, give that a shot. You know, that could be really useful for redoing the assignments in R. So that, I really appreciate this talk, especially the random forest for missing value imputations. That's just doing what, the thing that I talk about in 411 is I always talk about how decision trees are really good for filling and missing values. Well, doing it with a random forest is like doing it with decision trees on steroids. So again, that's another great technique.
Well, thanks, Don. And I think, like everyone in the program says, don't be a one-trick pony. Make sure that you're learning all of the other softwares that are out there, like Carlos and Azure and SAS. I think there's Tableau people are using. So just learn as much as you can, 411 folks.
Thanks for saying that. And everybody remember this with Susan. When you're taking my 498 capstone class and you're like, I hate working as a team. Susan, what do you think about working on a team?
Oh, I am so excited. I feel like we've got the best team. I've got Carlos and Chris and Rob, and we just started right at the beginning. We said, we don't have time to mince words. We're going to be genuine with each other. We're going to tell it straight. We're going to be organized and get the job done. And we have a really good mix of talent, and I just appreciate the team members. It's been a really, really good experience. I would recommend, when you guys have a chance to get to your capstone, find a great team and really just make the best of it. It's just awesome.
Yeah, it'll be what you make of it. But yeah, thanks very much. Great talks, all three of you. Does anybody else have anything they want to talk about? I'm going to try to do another one of these this quarter, but I can't guarantee it. So if you're thinking about it, this is the time to dive in the water.
Can we go again if there's another topic we want to cover? You do it again.
Go again. Oh, you mean do a second one tonight?
Yeah, I'll do a different topic. Yeah.
Wow. Is this Jim Anderson again?
No, it's Carlos.
Carlos. Save it. I'll tell you what. Let's save it for the next one. How about that? Because
okay. No, I mean not today. I mean if you hold another one of these sessions.
Oh yeah, you could do as many of these as you want.
Yeah.
I'm thinking about doing another one again later this quarter. But
yeah, we're all learning some neat stuff, so I think it's worth sharing.
Yeah. Guys, thank you so much for volunteering. I see I got a chat. Let me see if somebody chatted something. Will Susan be sharing her presentation? Susan, could you also, could everyone who has slides email them to me, and then I'll post them also to the 411 classes?
Oh, certainly.
I appreciate that. And if you guys could also post yours to the 498 discussion board information sharing section, that would be really useful as well. So anyways, guys, I really appreciate you volunteering tonight. I know it's kind of scary, but it's very useful, and students tend to get a lot out of this just seeing what people are working with. So my most sincere appreciation. So
Thanks for the
anybody else?
opportunity.
Well, I'm going to stop recording.